Bismillah Rahman Rahim. Sorry, folks, I'm late by a few minutes. There was a technical issue with the computer. I hope I'm audible. Can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you very much. Welcome, ladies and gentlemen, to the 11th episode of Pakistan Agriculture Policy Debate. We are handling this series on behalf of Pakistan Academy of Sciences. Today we have a very interesting topic. Originally, I had proposed chickpeas only, but then on the suggestion of Dr. Mubarak Ali, we changed it to pulses and chickpeas, people's protein in Pakistan. Interestingly, Sania Nishtar messaged me. So, what do you want to, prove through this event? I told her that this is probably the major protein supplier to the masses in Pakistan. That's why we want to say it, people's protein. This is an important subject, not only because it's part of daily diet, but for Pakistan, it's a challenge. We are importing pulses and chickpeas off and on to the tune of $1 billion a year or even more. And it is becoming costly by the day, particularly with current inflation trend and after COVID. We know that the cost of moongs have almost gone up by 300%. So there are so many issues on the table, but today we have a very competent panel with us. I'm grateful to Dr. Munawar Kazmi, who has helped me organize the team, and my personal gratitude to Dr. Kadambos Siddiq and to Professor Douglas Cook from UC Davis. We would like to begin the event by asking Dr. Mubarak Ali to give his opening remarks, and then I'll go to the panel. Dr. Mubarak Ali, over to you, please. Dr. Mubarak Sahab hain?
I think वो नहीं है डॉक्टर साहब इधर.
अच्छा चले ठीक है फिर. All right, we move on, and as suggested by Dr. Kazmi, our first speaker would be Dr. Rajendra Adhikari from University of Queensland. Dr. Adhikari.
Thank you, Dr. Ikrar Saab. Assalamu alaikum and good evening. My name is Rajendra Adhikari. Can you, by the way, can you hear me?
Yes, Raj, we can hear you loud and clear.
Thank you very much. My name is Rajendra Adhikari. I'm from University of Queensland, Australia. It's a midnight here, so if I fell asleep during my presentations, please excuse me. I would like to express my sincere gratitude and thanks for the organizer,
Raj, we lost your voice.
Sorry. Assalamu alaikum again and good evening. I'm Rajendra Adhikari from University of Queensland, Australia. It's midnight here, but I feel very much honored to have this opportunity to present, and therefore for this opportunity, I would like to thank the organizer, Professor Ikrar Saab and Dr. Kazmi Saab for coordinating this event. Before going to my topic today, I just want to give a bit of background to my connection to affiliations and connections to Pakistan. So in meantime, I would like to share my screen so that I can share the presentation.
You could share the screen.
Yes, I'm trying to share that screen, Dr. Sir.
Yes, it's working.
Okay, title of my today's presentation is about developing value chains of pulses, research for development perspectives. And this is a part of two presentations in a series. This presentation would be followed up by a presentation of Dr. Liz Peterson from University of Western Australia and a colleague of mine. Together we are in a project which has a very similar name to this, developing competitive and inclusive value chains of pulses in Pakistan, which was about to commence, and we were hit by the COVID. So we are in that we are in its first year of implementations in that sense, but have been hindered by COVID very much so far. So, but today's presentation is more about the situation. My presentation is on situation analysis of pulses in Pakistan. So before that, let me quickly give my background here. And as I said, my first relationship with Pakistan as a professional relationship with Pakistan was as a part of my job back in 2013 when I was in the Ministry of Agricultural Development in Nepal as a Joint Secretary of Policy and International Cooperation Coordination Division. And I had the opportunity to lead the Nepalese delegations for the first joint working group meeting in Islamabad in 2013. That's a bilateral cooperation mechanism between Nepal and Pakistan. This is from my memory at that time. And building on that relationships, I joined in 2015 as a researcher in value chain management with University of Queensland. And during that role, I had the opportunity to develop a project, to coordinate a project development process for Pakistan in pulses. And that's how I have been related to Pakistan. And while doing my PhD in Australia, my best mates were from Pakistan as well. So half a dozen of my best friends were from Pakistan. So I have both personal and professional relationship with Pakistan. That context would be helpful, I guess, in terms of my presentations and my perspectives into the context of Pakistan pulses. I would like to disclaim here that the data that I'm going to present here are, the information is based on the data we collected as a part of ACR funded project in 2 projects. And this project that I'm currently coordinating is a part of that projects as well. And I would like to express my sincere thanks to Liz, who has been very helpful for me in this presentation and in terms of following up from here. You all know, and I don't have to express this. This is well-known facts, but for me, it is very much important to understand why pulses, why and Pakistan and pulses are so intricately related here. The Pakistan is the proud proponent of the International Year of Pulses, in that sense that United Nations declared that year as International Pulses on the proposal from Pakistan when it first expressed its India views of 38th General Council meeting. So there are a few figures that I would like to share first. Per capita basis, although Pakistan is one of the, all South Asia region is a pulse consuming countries in that sense. Pakistan is still behind in terms of the per capita consumptions with its neighboring country India, most significantly, but not very much with others. So that shows that there is still more opportunity to develop the the demand for pulses. It is it was the fourth largest importer, and this could have changed since we have this data 2017 one. But the sad fact about pulses in Pakistan is over the last 50 years, the production has declined by more than 30 by about 37%. And in terms of the importance of the pulses here, chickpeas and mung bean has a higher share in terms of their production, and followed by mas and masoor as well. As I said, in 2018-19, according to the Pakistan government's data, 570,000 tons of pulses were produced. But if you look at, like in terms of the productions, Pakistan's is way down here in terms of productions, not even in the top 10. And then if we look at the figure here of the production of major pulses, there has been significant increase in the production of mung bean, but decrease in other pulses species. Species, and that's this decrease in production has not been experienced by other crops, and that's important here because when we are talking about the pulses, it's a relative for smallholder farmers because they all care about the profitability out of their crops in disposal. Area in production as well, approximately 5% of cropland is sown in pulses each year. Pulses are also, therefore it is a minor crop for Pakistan in that sense, but see the major crops are there: wheat, rice, cotton, maize, and sugarcane. And looking from the, the partially insiders, but mostly outsiders, we clearly it says we can see that there is a sort of priority or focus on these major crops. But this has been changing in terms of the policy, and I will touch to that point a little bit later. Whatever it is, the driver for any area of production is the profitability. We all know, and for that matters, yields, farm gate price, cost of production, all relative to other crops is the major drivers. Clearly, the area of production has not been increased significantly compared to its the competing crops in terms of the season. In terms of the yield, the mas has a higher yield compared to chickpeas. 5 years average. If we look at the 5 years average, it revolves around 0.5 hectare per 5 metric ton per year, and that's nearly around half of what the rolling average for 5 years in its neighboring country, India. So because we have similarities in many areas, climatic similarities, soil similarities, and so many things, its potential is there to increase that yield gap. So, sorry, I can't follow up the message, but I will address later on. So, as a part of that project that lead before the policy project, there was a survey on what are the constraints of this difficulty in terms of the increasing yield, increasing production area under productions, and overall productions. Clearly, there were two aspects very vividly expressed. Let me just quickly check because I'm following. Sorry. Yep. So technical aspects and financial aspects were vividly reflected in terms of smallholder farmers' response to the survey questionnaire. And seed quality, cost-effective method of pest control, labor-intensive management practices, cost-effective method of weed control, availability of seed were the most important factors for smallholder farmers in terms of their the problems they were facing. Besides them, there were financial factors as well. For example, availability of credit, relative profitability of pulses, vis-a-vis other crops, and other market factors. In the process of developing this project, we have number of interactions with stakeholders in Pakistan, and we also realized that there were other important factors that were also hindering the development of pulse industry in Pakistan, and these factors were social and value chain factors as well as policy factors. In terms of the seed quality, this is alarming in a sense that availability of improved seeds as a percentage of total requirement of pulses is, say, in this graph here, we can see this is negligible over there. It falls around the mark of 3%. And so by having a 3% improved seeds, it clearly gives us an opportunity. I would not only see it as a problem. Yes, it is a problem, but it's a big opportunity for all of us to improve that yield gap, because if we can raise that by even tenfold, what can we imagine there? So this is the serious area of concerns in terms of, I'm talking about the value chain perspective. Seed is the first and foremost area of value creations for everyone, and if that's the area which is lacking a lot, then we can see the problem, where the problem lies. So these areas, breeding, certification, registration, and distributions are, we all it has well been recognized as important area in terms of that, and Pakistan National Food Security Policy clearly outlines this as an important policy priority. There are other areas which, from our knowledge working in the project, there clearly gives us that private sector engagement in seed industry, strong public-private partnership, value chain integrations of the seeds suppliers and producers with market actors, and community engagement in seed multiplication and exchange are other areas that can really be supportive in these areas. And for that, research, extension, and capacity development is crucial, and we would like to understand the root cause of these problems as a part of our research effort in this project that we are having. So the second factor, the price. Price here is a sort of double-edged sword in terms of the pulses in Pakistan. So at one end, the consumers are facing this soaring price. At the other end, that price that consumers pay actually has not been reflected as an incentive for smallholder producers to grow more pulses, and that is vividly again reflected in the areas under pulses. And if we look at this graph here, from 2006, the prices of pulses has been continuously growing, except for Mashur in recent years. And that was the area, that was the year when, with a policy intention to curb the domestic consumer price, export tax was imposed at the rate of 35%, which later changed to export ban in 2016. And this is area Liz would be covering, so I would not focus that much. But what I would like to say here is, during the period of 1991 to 2018, the variability of pulse producer prices has been lower than other major crops in Pakistan. And even with faster increase in price and lower variability of prices, the area planted under pulses has not been kept at the same level or at that in proportion to that increase. So one possible reason that that the research has shown that the cost of production has risen faster than prices in pulses, and that's that can be seen in this slide here. The mass masoor cotton, mass masoor and gram has a higher, the cost of productions in, compared to rice, wheat, and maize, and resultant effect is, and based on again the study that Peter Lees did as a part of our projects before, the gross margin for the per unit area of land is low for chickpeas, masa, and mung compared to wheat. And so, all what this shows is this this is a complex problem that we are dealing here, and obviously we need a holistic approach of research development and research and development. So one of the holistic approach, and that's quite becoming a sort of in international agricultural development, a sort of widespread approach, becoming a widespread approach of international agricultural development is a value chain approach. And that approach we are trying to look at, we are using in the project that I discussed before. So with that value chain approach, our intention is how can the smallholders, pulses growers can get the fair share of their contributions to the industry or price, out of the consumer price. And we have clearly identified the policy aspect is one of the important area where which also need to be addressed. In particularly, not only the technical, not only the other financial, but it's the policy aspect needs to be considered as well. And from my own experience of working in policy in developing countries in South Asia, my perspective is policy can in recent policy can be in a document as a consensus document for all that has to be clear, concretely instrumentalized. So we need to have a concrete instruments that translate the policy into practice, and that has to be shown in terms of the budgetary commitment, in terms of other types of enabling policy, creating an environment, and somewhere we this is an area that we all need to work together if we want to solve these problems in this very wicked and complex problem in a timely manner. So because of that reason, there is a project called Developing Competitive and Inclusive Value Chain of Pulses that I said before, and its objective is to support the development of socially inclusive and competitive value chains of pulses, particularly focusing on Punjab and Sindh, with some effects expected in to KPK as well, with the following 4 objectives. I have not read those 4 objectives, but it's clearly, it has a research component of understanding what are these barriers and opportunities. And then the second is this, it has a capacity development component for smallholder farmers and value chain actors. And the third component of which we want to support the dialogue and discourse around this policy, so that, I firmly believe that it's the Pakistani governments and Pakistani stakeholders, authority around the policies, but we are happy here to create a sort of providing the the support services that can actually be a help in that discourse, policy discourse. And ultimately we want to demonstrate that the value chain model works in pulses in Pakistan, and that's from I will not touch upon these three objectives. The third objective here, the policy, very relevant to today's discussions, and one activity that we want to support is we would like to provide a sort of policy platform like this, actually, like in the future as well, where we can have this meaningful conversations around the what best policy it could be. And as a part of our research, Liz is working on, and our team is working on, what can be the best policy agendas and options in terms of developing the policy here. And so sort of policy industry development strategy, we would like to support in that strategic process and lead. That's my presentations, and Liz will follow these presentations with based on this situationalized. She would come up with some sort of suggestions that we believe could be different options for Pakistani stakeholders to consider and move from there on. With this, I'd like to say thank you to all. And if there are any questions, I'm very happy to address at any time of your convenience, sir. Thanks a lot.
Thank you, Dr. Adhikari. You have actually set the stage, and that our pulses production has been declining since 2007, and 13 years that we have not been able to arrest it. And this week, world has seen Nobel Peace Prize going toward food program. I hope that there are lessons for us to learn and see if we could be looking after our food security, and particularly pulses, the essential items. Before I ask Liz Patterson to speak on the subject, I would like to once again invite Dr. Mubarak Ali, who has joined, and ask him to put the case in perspective. Over to you, Dr. Mubarak Ali, and then I will invite Professor Liz Patterson. Mubarak Ali. Mubarak, what is our huh? Okay. Okay. Okay, we have your screen, sir. Yeah. Please unmute yourself. We cannot hear you. So the pulses area is constant or declining, and wheat going up. Oh no, it's yield actually. Not area, but yield. Ji, Dr. Mubarak Sahib. उनका देखे म्यूट तो नहीं. Huh? Please unmute yourself. You are mute.
Can you hear me now?
Yes, we can hear you now. Please go ahead.
Okay. I think this is Dr. Mubarak Ali. I'm sorry I could not prepare very formal presentation because of shortage of the time when I get engaged into it. But proteins are, these pulses are very wonderful crops. First of all, it's a very cheaper source protein, and also a reasonable cheaper source for iron as well. Although its bioavailability of pulses of iron in pulses is very low, but there are studies which have shown when I was in RDC that its iron bioavailability can be enhanced from 4 to 16% if its proper cooking procedures are adopted. And it also helps in anti-cancer elements and other cardiovascular diseases as well. So, but then pulses, the cause of pulses is actually can be seen in these slides. This is the history of the crisis of the pulses. You can see the per hectare yield of wheat which has increased from 1,200 kilogram per hectare to about 3,000 3 tons per hectare, compared to the yield of pulses remain about fairly stagnant, or if not declining actually. There might be some declining trends. People were saying that it's not only the yield is stagnant, but also the research could not produce the varieties which are input responsive, unlike in wheat and rice. You remember when we gave Mexipoc, which was very input responsive, irrigation responsive. So we built new institutions to provide fertilizer, we built dams to provide water because those varieties was input responsive, but all the varieties of pulses in Pakistan are not, except some in mung bean now, but all the other crops actually are input responsive. That's why actually, as Dr. Rajinder mentioned, that there's low credit availability, low seed availability. The government is reluctant to invest on these fertilizer credit, as well as on water availability for pulses, because these varieties are not input responsive. So not only this, because of this situation, because of the research was not really focused on input responsive varieties. So what happened was basically that all the pulses were driven or pushed out of the intensive system towards the marginal lands. For example, during 1973, the marginal lands in Pakistan, Mianwali, Laiya, and Bhakar, has only 5% of the total pulses grown in those areas. But then during, now it's 95% of the mung bean is grown in that area. Before it was only 5%. This data is only about the mung bean. So similarly for other crops, what happened was that these pulses were pushed towards the lands. So I think all the crisis of pulses is not only the policy pulses, but policy crisis, but also because of the laxity of the researchers to pay attention on improving the yield of pulses. I was told that it was very difficult to bring the high yielding varieties or input responsive varieties in pulses, unlike in wheat. But I think that might be true 10, 20 years before, when we do not have the biotechnological approaches. When now we have the biotechnological approaches, I think that should not be the much constraint to push the frontier of pulses productivity upward. I think we have a very good example of mung bean. I was part of that mung bean revolution in Pakistan, as shown in earlier slide also, that mung bean production is increasing, that actually the yield is also increasing. We were in Taiwan, I was in Taiwan with AVRDC. I brought $10,000 and also the high yielding mung bean varieties from Taiwan to Pakistan, but when those varieties were grown in Pakistan, they were all eaten up by the yellow mosaic virus. So what the Nuclear Institute did, they put those material in the gap, they put the Pakistani varieties in the gamma rays, and they changed the strains and find out some strain was very, very responsive, very yield yellow mosaic virus resistance. So we incorporate those yellow mosaic resistant strain into the high yielding varieties coming from Taiwan, so that we were able to develop the high yielding varieties. Later, research was also focused to make it a uniform maturity. You know, most of the mung beans are not uniform maturity, have uniform maturity, so you have to accept grams. I think grams can be harvested one time, but then like lentils and others, and especially mung bean, you have to harvest it many times, that increase the production cost. So I think the more emphasis need to be given to increase the yield of these pulses. Actually, Pakistan and all the Southeast Asia have to face the choice that whether they have to import pulses worth of $700 per ton, or they have to export rice versus US dollar 120 per ton. Even though the yield of the farmer is 1/3, if you multiply 120 to 1/3, it will be 360 versus $700 per ton. So I think the choice is very clear that whether we have to continue to put more water as well as more cost towards rice, or importing it, $700 per ton of pulses. If free market forces are allowed to operate and policy biases against pulses are removed, shifting crop area from main cereals to pulses can clearly produce economic advantage along with the resource conservations. Another advantage of the pulses is that they are leguminous crop. So they give the benefit of sustainability of the rice wheat, especially to the rice wheat system. So I think incorporating mung bean in the rice wheat system can also enhance the sustainability of the crop. In fact, we demand public support to expand pulses beyond market forces on the grounds of their impact on sustainability of the cropping system. Increased demand of pulses for cardiovascular and diabetic protein, health, improvement of the poor, and increasing labor productivity. The technology innovation should focus on high yielding, short durations, uniform maturity, disease resistance, and input, especially irrigation responsive varieties. One problem with the researcher is they wanted to increase the productivity of pulses in the marginal lands. You can do that, but that will be very marginal increase, not a big jump in pulses yield. Unless you make the pulses input responsive so that they can be grown in the main areas, pulses will remain a marginal crop, a very small crop in the marginal areas. So I think research focus has to shift not to produce high yielding in the marginal area, but make it input responsive so that it can be brought into the mainstream production systems. Okay. Such technology will not only transform pulses from subsistence to commercial crops, but can also be helpful to bring them back from the marginal areas. Integrated pulses in cereal-based system in South Asia will improve the food security on small farmers by increasing their income and enhancing the sustainability of the production system. The AVRDC experience in mung bean is very, very important. I think AVRDC tried to also had some successful experiments of incorporating mung bean in the rice wheat systems. I think that should also be tried in Pakistan. There are these variety, mung bean variety can be matured in 55 to 65 days. So I think there is a window available after the harvest of wheat before the start of the rice to put the mung bean in that window. Pulses are not only dense, but also cheaper source of protein and iron. As I mentioned, the bioavailability of micronutrient in pulses can be enhanced by developing appropriate cooked dishes, which are locally acceptable and palatable. And there are experiments actually done in India to show this, to show the enhanced bioavailability of iron and thus improvement in the children's performance in school. Nutritional education of women through electronic media should be complemented with these efforts. This will not only enhance the food security of the poor in general, who can rely on pulses for the cheaper source of protein and iron, but also improve their health, productivity, and earning capacity of the neglected sections of the society, especially women and children. Thank you very much. This is what all I wanted to say. I think it is not the problem. The pulses is not the problem. The crisis in pulses is not just the problem of the high level policies, but also at the research level, where researchers are thinking that pulses is just a margin crop and we should increase its productivity in marginal areas. We should try to make it input responsive so that it can be brought into the mainstream cropping systems. And also we should increase the resources for pulses in research institute and universities. Thank you very much.
Thank you, Dr. Mubarak. You have said it very well that it is not only to be left to thal and briny areas. Why not in irrigated agriculture? All right, so we move on to Liz Patterson. She is joining us from University of Western Australia, Perth. I hope that there is a time difference between Queensland and Perth, so she is a little comfortable than Dr. Adhikari. Over to you, ma'am.
Thank you very much, Dr. Ikra. I appreciate very much the opportunity to speak today. And I live in Australia, but in Western Australia, so it's only 10:45 here. So I think Rajendra's got it a bit harder than I do. But yeah, thank you very much for this opportunity. I'm very grateful for it. And Dr. Mubarak Ali, that was a fantastic presentation. I agree with you 100% that it's an issue about policy, but not only policy, but it is all about getting pulses, productivity higher, input responsive, so that the profitability is higher and they're not just grown in marginal areas. So I'll just, okay, I'm just trying to share my screen at the moment. So please let me know. Is that clear to everyone?
You're good. Please go ahead.
Excellent. Thank you very much. So my presentation now has two parts, and I think it does flow on quite well after our last two presentations. And I'll be talking initially about government policies relating to pulses, and then trying to draw from the work that the other last two speakers spoke about, as well as policy, to then look at how do we go through to the future. We can see some of the problems, and we can see that we'd really like to increase yields, make them pulses input responsive, and now how do we go forward? How can we develop a strategy to go forward? So if I just start on government policies relating to pulses, there's just the one government policy that directly relates to pulses, and that's the export ban. But there's a number of other policies that are related to pulses, but indirectly related to pulses. And they include the wheat market price support scheme, fertiliser subsidies, and electricity subsidies that I'll also mention. But first, if we talk about the export ban, so in 2006, as a response of escalating exports in pulses, as you can see from that graph, Pakistani government introduced a 35% tax on exports of pulses. And then 10 years later, this was replaced by an export ban. And you can see that exports decreased to almost nothing with the introduction of the tax, and then nothing with the introduction of the ban. So we were thinking about, there can be possible justifications for an export ban. It might be or an export tax, maybe to raise revenue in the case of a tax. It's good to encourage the development of downstream processing sector, and it also can be introduced to suppress prices for the benefit of consumers. But unfortunately, as we've looked at the data, these justifications have not been entirely fulfilled. So the tax was quite high that was introduced. So there's really little government revenue raised from the tax and no government revenue raised from the ban. I think arguably there has been development on downstream processing sector, but I would say that has been limited, and I'm not sure that has the export ban really has had a great impact on that development of processing. And then unfortunately, as Dr. Rajendra has noticed, that since the tax and then ban was imposed, domestic prices have been higher. So unfortunately, and it depends on whether you're a consumer or producer of pulses, but from a consumer point of view, prices have gone up considerably, and input prices have gone up too. So the profitability to producers haven't gone up too much either. So given that we don't believe that the export ban has really had a positive impact, we are recommending the removal of the ban. And the main reason I'd like to recommend the removal of the ban is that we would really like to increase the productivity of pulses. But as you increase the productivity of pulses, if there's not a bigger market for those pulses to be sold into, then that will just lead to the decreasing in prices, which is good for consumers, but it's not good for farmers. So as farmers increase productivity, then they'll be producing more, but because the market's not growing, the market's only the Pakistani market, then the prices will fall. And we have done some modelling to say that producers will be worse off with productivity gains if an export ban stayed in place. So this is our recommendation, that the export ban is removed on pulses so that any productivity improvements are at the benefit of the farmer. And this involves removal of pulses of all sorts, gram and gram flour, from Schedule 1 of the export policy order. Okay, so there's only that one policy in Pakistan that directly relates to pulses. Other domestic support for pulses is shown in this table. This table is now 5 years old, but I haven't been able to get any, I don't think there's been any more recent data published on this. But it's published by the World Trade Organization, and it's the value of government support in various areas. And what's called green box measures are positive things. They're good things that the WTO would suggest would continue. So there's a number of good green box measures of support in terms of irrigation system rehabilitation, the provision of wheat storage facilities, agricultural extension, and other measures that are quite good. But with the amber measures, these are the measures that the WTO would say are not good for an economy. It causes price distortions and other problems within an economy. And that includes a wheat price market support and the fertiliser subsidy, and to a lesser extent, the electricity subsidy. And you can see here that Pakistan does spend a lot of money on the wheat market price support, $647 million US. In 2015, and almost the same amount in fertiliser subsidies, $566 million per year. The wheat market price support does distort the market by favouring wheat production over other crop production. So by increasing the prices that wheat producers receive, it makes it relatively more profitable to produce wheat compared to other crops that don't have this price market support. So pulses don't have this kind of support. So this is really encouraging farmers to be growing wheat rather than pulses. So if we believe there's dietary benefits, there's rotational benefits, there's a number of benefits in growing pulses, then the wheat market price support is preventing the growth of the area of increasing of pulses produced in Australia. And it is, I believe, quite inequitable in that not even all wheat producers receive this market price support. And moving on to fertiliser subsidies too, this also distorts the market by favouring crops with relatively high fertiliser requirements. So the value of fertiliser inputs for wheat is about 6,725 rupee per acre. For mung is about half of that, and for chickpeas nothing. So the fertiliser subsidies are then encouraging production of crops that need a lot of fertiliser at the discouragement of crops that don't need anything. So again, this is a measure that's really discouraging the increase of pulses production in Pakistan. So we recommend the phasing out of the wheat market price support and fertiliser subsidies to make it more equitable in Pakistan and to encourage the growth of pulses production in Pakistan. So that is all I was going to present about policy. So onto the second part of my presentation, which is not only about policy now. This is drawing from what Dr. Rajendra has talked about and Dr. Mubarak Ali has talked about. So we have declining yields, we've got declining area and declining production of pulses in Pakistan. We've got an increasing market for consumption in Pakistan and elsewhere. And how can we meet this, allow more production to be grown in Pakistan? So the Pakistan government is keen to develop a strategy for a way forward for pulses production. And we have conducted some initial research that Rajendra has discussed. And we've also done some initial consultation with government universities, private sector, NGOs, and others. This is really just an initial consultation to draft some ideas around a strategy, which we have done. And now we'd like to really go to more people. We want to present it to Pakistan. What do you think about it? We're really keen to have your views, and we just see this as a starting point for discussion, really, and that we hope that discussion will grow and that the strategy will develop into something that Pakistan is really proud of and really wants to implement for the good of their pulses sector. So when I'm presenting perhaps the skeleton of the bare bones of the strategy that we have drafted, there is a lot more detail in it that we can send out. We're really keen on your views. We want to change it, adapt it, whatever it takes really to make sure it's a strategy that is owned and supported and Pakistan is very proud of. So we have a vision here. I'm just going to move, I can't read it all. We've got an overall vision for the Pakistan's pulses sector strategy, and that is a competitive, adaptable, inclusive and sustainable pulses sector, contributing to the socio-economic well-being of all members of the pulses supply chain and contributing to development of the national economy. So again, this is a vision that is our first stab at it after our initial consultation round. Very keen for your views. Please send them to myself or Raj on how you think that vision can be improved upon. So once we have the vision, we then want to know how can we achieve this vision. So in our draft strategy for consultation, we have 3 interconnected strategic objectives. They can't be achieved in isolation, they're interconnected. And then associated with each strategic objective is a number of actions. So the first strategic investment objective is to increase productivity in Pakistan's pulses sector through increasing yields and capitalising on opportunities for intercropping and between season sowing. So this has a number of actions against it, but it's all about productivity. How can we increase yields and increase the area? We think by increasing yields, it'll move out of just marginal areas, but it's not only marginal areas. We see there's a great opportunity for intercropping and between season sowing. So these are now the potential actions associated with this first strategic objective of increasing productivity. And I just present it here to show that we have some depth to these suggestions that we're keen to get your feedback on. First is about modernising the seed sector, because at the moment I think it's really just Indigenous seed that is grown. It's not improved seed, it's not input responsive seed. And then after improving seed sector, I think we know largely what the best management practices are, but it's about then extending what these best management practices are. So the second action is around developing capacity for participatory extension processes. So that's strategic objective 1. Suggested strategic objective 2 is to develop the pulses value chain to improve linkages, capacities, information flows, and distribution of value between all value chain participants. So this is now looking at the whole value chain. It's not just increasing productivity, but it's now then helping to improve efficiency along the value chain. We have another number of potential actions that you may like to have a look at some stage. I won't go through the detail, especially we can send you the documentation for you to have a look at. And then our third interconnected strategic objective is to strengthen the policy and institutional environment to increase the competitiveness of pulses production. So our first objective, as I mentioned, is productivity at the farm. The second is efficiency along the value chain. And this third one is about this overall policy and institutional environment for pulses production. And then we have a number of potential actions associated with this. So it's about providing evidence-based decision support for government for critical policy issues, such as we've talked about the export ban of pulses and price support for wheat, fertiliser, electricity subsidies. It's about increasing funding in research, development, extension and adoption. So research into maybe improved seed, the development and then extending it to farmers and then getting adoptions. So right the way along that adoption pathway. And also to encourage industry leadership and funding to support the development of the pulses sector. So that's really just the bare bones of a start of a potential strategy in Pakistan. I'll leave it there, but we're really keen for your views and your feedback and consultation so that we can develop and improve on it. So please let myself know or Dr. Rajendra know if you'd like a copy of this strategy, and please let us know your views. I'd be delighted to hear them. Thank you very much.
Thank you, Dr. Patterson. A very impressive plan, and we hope to, get some of your ideas accepted by the policy, and we'll continue the advocacy that we can do at our level. Okay, after these three social sciences perspectives, now we move on to purely technical side. We have two probably the top names in the subject, Professor Kadambo Siddique and Professor Douglas Cook. So first I'll request Dr. Siddique, and then I'll ask the final and the major presentation from Dr. Cook. So Dr. Siddique, first over to you.
Thank you, Ikrar. Good evening. Assalamu alaikum.
Wa alaikum assalam. Welcome.
I'm very privileged for the invitation from you, Professor Khan, and I thank you and the Academy for the invitation. And it is also great to see some of the familiar faces, both from Australia and, of course, United States and Pakistan. My association with Pakistan is almost more than 2 decades, but during the last 1 decade, particularly through University of Agriculture, Faisalabad, there has been tremendous collaboration both ways, both from University of Western Australia and from UAF. So I'm grateful to you again for that wonderful collaboration still going on. And we have 7 PhD students currently undertaking as part of the joint program between University of Western Australia and UAF. With that introductory remark, I'm going to share my screen. Please let me know if you can see.
Dr. Patterson, you have to remove your screen so that Professor Siddique could take it over.
Can you see?
It is about to come. Yes, your name is. Yeah. Yes.
I have shared it.
Yes.
Can you see?
Yes, it's clear.
Okay, now. So we heard from, in fact, the scene has been set by the last 3 speakers, including Rajendra, Liz, and also from Pakistan. It's very clear that the pulse production has been static of constraints. We heard the policy constraints. So that's well covered. Now let us look at some of the other biotic and abiotic constraints. I'm sure that my colleague Doug Cook will cover some of the aspects. So I'm going to talk about drought, adaptation to drought. Drought is an important part of the Pakistan's agriculture, and hence this makes a major emphasis. Unless we improve the productivity of the current varieties, either through biotic and abiotic stress tolerance, we are not going to achieve that vision Liz has just articulated. So I'll just, in the brief 15, 20 minutes, I'll just cover a background, the climate change and drought, largely from Australian experience, but it has got a similar situation in Pakistan. Germplasm, which is the backbone of any bit of drought physiology. Then we heard from the second speaker, the new technology, the genomic assisted breeding is absolutely a must. And Pakistan has got some wonderful scientists and capacity which can boost that pulse production through that program. Then I'll draw some conclusions. Before doing that, I would like to proudly show my University of Western Australia, which is situated on the Swan River. Professor Khan, you may recollect your visit. And I'm here in Perth, the capital, and the state is large. This is the second largest state in the world. The first one is somewhere in the Soviet Union. So this is our main campus, and my office building and laboratories are somewhere here. We are an internationally recognized university, ranked top 100 in many rankings. The most important aspect is well-established industry partnership. This is so important for Pakistan. Yes, you guys are doing wonderful to build up that relationship with the industry. That is so important. We are part of the Group 8 universities in Australia. And you will see that we have the Nobel Prize winner, Professor Barry Marshall, for the medicine, that is the Helicobacter pylori, the stomach ulcer. He's a very close friend of mine, and we have been traveling and working together in various parts of the world. That gave us Nobel Prize in 2005. The university ranking is very important, international ranking, and being an academy, Pakistan's Science Academy, it is important to mention. So the overall ranking, we are sitting 85, just came out a couple of months ago. This is the academic ranking of the world universities. It's based on metrics and also the papers published, the citations, the quality of the staff, and so on. Life and agriculture science, we were about 24, 25, 24, and 2017 onwards, the agriculture science separated from life science, and we have been hovering around 14 to 17, and first in Australia in agriculture science. It's a small group, but we do work very hard to stay on the top of the game. In this particular talk, it's not only my work, many colleagues, including particularly my research fellow, Dr. Jane Pang, and many other familiar faces and visitors are here. Someone mentioned about the 2016, the International Year of the Pulses, and privileged to be the ambassador for the special ambassador for the International Year of the Pulses, which really helped to boost production in many parts of the world in pulse production. Despite that, we are really seeing significant problems in pulse because the global investment in grain legume research development is very low compared to the cereal crops, 175 million per annum in 13. So if you take the same statistics in Pakistan, you will find that investment in pulse are much lower than wheat, maize, and rice. And we have articulated that in a paper published a few years ago in Nature, and you can download or just contact me, I'll give that. Chickpea, you all know that it's a self-pollinated diploid food legume, originated somewhere in the Fertile Crescent, grown more than 50 countries, including your country, Pakistan. And it is second among food legumes world production. There are two types, Desi type and Kabuli type. I don't need to describe that to you people. High protein content, fiber, minerals, and folate, folic acid. More importantly, as previous speakers mentioned, the rotational benefit, leaving substantial amount of nitrogen for the subsequent crop. And its input is much less than compared with Hungary, wheat, rice, and maize. I won't go into the details of the production, and we have been seeing some increase in world production, largely because of the increase in production in Australia, then Myanmar, and more recently, the last couple of years in India. Although the Pakistan situation has been very clear, and also Turkey, it has not been moving forward. In Australia, chickpea is a new crop. In fact, my PhD was the first PhD proper research on chickpea, which I undertook in the University of Western Australia. We had a problem, initial increase in the 90s, and then Ascochyta blight came and devastated the crop. Then we started good breeding program and bringing germplasm from both Ecrisat and Icada. And we have now moved over that situation, and we have been producing about 1 million tons of chickpea from nothing. And it is significantly low compared to the big producers, but 90% of that is exported into the international market. Where do we grow our chickpea and pulses? And we grow what we call the grain belt of Australia. The grain belt is stretching from the southwest, then southern Australia, Victoria, all the way to New South Wales and Queensland. That's about 300 to 600 millimeter rainfall ISO height. So purely dry land, entirely depending upon current rainfall or stored moisture. So drought is a major part of Australian continent, and hence drought resistant varieties are important. And of course, as you know, the projected climate change, and Australia is going to suffer, is suffering. And if you look at the key climate variables, 2030, which is not far away related to 1990, you can see that the most part it will be increase in temperature, decrease in rainfall, particularly in that area, and evaporation, except in the northern bit, the rainfall is going to increase. So we're going to face significant increase in temperature, declining in rainfall, and as a result, we have to develop drought-tolerant varieties of all crops, including chickpea. The terminal drought, I call, which is very common in Pakistan, the soil moisture stress that occurs during the flowering, pod filling, and seed development stage. This is a major constraint, more than 80% of the global chickpea area, and hence we must continue to improve production through developing drought-tolerant chickpeas. So what we did, overall objective in a project, we want to identify chickpea genotypes with resistance or tolerance to drought in a Mediterranean type environment, meaning no summer rainfall, it's all winter rainfall leading into terminal drought. We wanted to investigate the underlying physiological mechanism and then from there take into the breeding program. So we used a combination of field work and glasshouse work. So we started from the field, so this is in Perth. The three sites I show, Bindi, Cunderdin, and York in different years. So 2012 in York, water limited environment, about 108 lines from 2,000 lines we started in large plots. And 2013 from the 108 lines, we moved into water limited environment at 2 sites, 62 lines in large plots. And then from there, we took 2014, selected 10 lines to understand the physiological basis of drought tolerance. So the field data is shown here, York 2012. You can see, as you expect, a range of yield in the genotypes, but just note the red and the blue here, that is high yielding, somewhere low yielding. But in Bindi, the position changed, but you still can see the high yielding remained high yielding. And when we move into another site, the high yielding remained high yielding and low yielding remained somewhere there. So the idea behind is that we wanted to pick up the high yielding phenology and understand why they are high yielding. So we used a technique of a glass house, but normally in the glass house, people use small pots, but I'm not very happy being a field-based scientist. I would like to have a large ones. So we used what we call the rubbish bin or wheelie bins. Of each pot had 100 kilogram of field soil arranged in such a way that it mimics the field condition. So it's normally 4 to 5 times larger than small pots. So those who are going to study drought, please do not undertake drought studies in small pots. That's the message I would like to see, to give the young scientist of Pakistan who is listening to this talk. So what did we do? We had 2 treatments, started at around early podding, the first podding stage around in September in our time. Well watered means there is no water stress, maintained about field capacity. Water stress means no water after the first podding. So you can see the wheelie bins. We designed a custom-based balance so that we can weigh the transpiration loss, and we were able to monitor the transpiration, photosynthesis, and so on. But you can see these white tags. So the research associate and others were able to tag the flowers which formed on a particular date, and we were able to follow their fate in relation to pod development, seed development. This is very important. I think they would have tagged something like 20,000 plants and different treatments. Now, this is the most important result. There are about 10 genotypes, including one of the genotype I developed here called Neelam, which was bred in Western Australia. And here we have got the soil water content, a percentage of the field capacity, 80% field capacity, which is well watered, and those genotypes which did not get water, you can see the soil water content. So starts water stress at first podding stage. And what you can see is that the pattern of water use is different. For example, Neelam, one of my varieties, used to water very slowly, whereas DICC 9073 used to water rapidly. The end result is that those used to water slowly had more water available during the pod filling, flowering, pod filling, and seed setting stage. The one which used to water rapidly lost water, were not able to produce a sufficient seed, size, number, and yield. I hope that's clear. Now, visually, you can see that Neelam on here, you can see the control. You can see the water stress is still about 13% of the field capacity, still surviving, whereas CICA almost dead. So that's the kind of thing I was mentioning in the previous slide. We looked at the floral biology, the pollen development. From our previous studies, we knew that the pollen viability is affected by water stress. The pollen tube growth is reduced. Finally, the pollen tube reaching to the ovary is also affected. So we wanted to look at that. So you can see here clearly the pollen viability in well watered is pretty good here. As soon as the drought comes, that reduces. Pollen germination, which is important. There also we have seen differences in genotypes and differences in water stress. So increased flower abortion, pollen tube growth into ovary could not guarantee the success of fertilization. Possible inhibition on ovary fertility. We also hypothesized that storage of carbohydrate supply and or hormones may be limiting. Just bring it. So this is, without going into the detail, the pods developed from flowers tagged on the same day, 80% of the field capacity, 50% of the field capacity, 2 genotypes. So this is WW stands for well watered, WS stands for water stressed. The first thing you can see that ABA, abscisic acid concentration increased dramatically with water stress, both at 80% and 50%. In 50% it is much more. Whereas in another genotype, we'll see that it's increased, but relatively less compared with the other one. Abscisic acid can reduce viability and fertility. For example, here it is the 16 days after flowering. In the case of water-stressed pods, this is the fate. In the case of 16 days after flowering, the well-watered plants. So drought reduced the seed size, as I told earlier. This is the mean seed weight, grams per seed. The red indicates the well-watered, and WS is blue. In all cases, it reduced, but the reduction varied depending upon the genotype. Now, let's look at the yield. So the seed yield grams per plant from those pots, and this is well-watered. You can see that there were differences, and keep an eye on some of the genotypes like Neelam. Now let us look at the seed yield under water stress conditions. Look at that. This was one of the high yielding lines, but as soon as the water stress came, look at their yield. Whereas Neelam almost still reduced yield, but look at the reduction was much less. So some genotypes were able to retain and produce more pods, partly because of the pattern of water use and also other physiological mechanisms. And this graph, the red indicates high yielding lines, the blue indicates low yielding lines. And this is the seed yield of water stressed plants and water use at different times after water was withheld. So in other words here, 104 and 106 days, those plants used more water earlier on, there was a negative relationship with the yield. Whereas here, the second graph, you can see that this is 112 and 117 days. The more water was available towards the after flowering and during the seed filling phase, had a positive correlation there. We also looked at, we have a platform developed here to rapidly study the root system architecture in Chickpea, and you can see here that we have screened the entire co-collection or reference set, which is about 300 accessions, and we were able to see significant variation in the root system, not only in depth, but also branching and number. This is so important trait in relation to nutrient and water uptake. So you can see, for example, trap root length. This is one trait. In the case of Daisy with the 207, you can see the significant variation. And in the case of Kabuli, also there is variation. And this is now being utilized for further studies on nutrient use efficiency and so on. So what is the summary part of my talk? Reduce the seed yield. Where is it coming from? Drought affects the pollen sterility, possible fertilization, failure due to ovary viability, or other factors like
Professor Siddiq, probably you are muted. Internet connection. Some connection problem with Professor Siddiq. Oh, is he coming back or? Professor Siddiq, are you on? Are we together? Huh? Probably we have lost connection with Professor Siddiq. Let's wait for a few moments. I think he was about to conclude in any case from terminal drought sensitivity to root length and biomass. Ji, Siddiq Sahib. Okay. He is out. Okay. Unfortunately, we have lost Professor Siddiq, but we have heard most of what he had meant to say. Let's move on to our final technical talk. I request Professor Douglas Cook to make his presentation and also tell us about his program of feeding the world. This week, World Food Prize has gone to, Nobel Peace Prize has gone to World Food Program. So I hope that you have some contribution in that too. Over to you, sir.
Okay, well, thank you very much. Can you hear me okay?
And you have heard our collaboration with Western Australia, and UC Davis is not any less than that. You are aware of
Yes,
that.
I'm aware of that. You can hear me okay, is that correct?
Yes. Yes.
Okay, very good. So I'm going to take a slightly different approach, I think, to my presentation. I'll talk a little bit about research outcomes, but really what I'm going to focus on are activities in my program at UC Davis on chickpea that have involved Pakistani scholars. Because, you know, for me, the important part of my career is less about research outcomes than it is about students that I've trained. And I've had the privilege over the last few years of having a number of Pakistani students and scholars in my program. So I'm going to tell you a bit about activities in the lab, but really what I'm going to do is tell you about the ways in which Pakistani scholars have contributed to those activities. So a major theme in my lab over the last a bit less than a decade has been looking at genetic diversity, particularly in wild plants and microbes, and trying to understand how that diversity, both at the genetic and trait level, might be useful in agricultural systems. Now, I was asked to add some recommendations at the end of my talk, but I thought I would give my recommendations at the beginning, both so you could think about them in the course of my talk. So the first thing that occurs to me is there was a fair amount of discussion about developing input responsive pulses. And you know, this seems like a strange objective to me because first of all, pulses aren't grasses, and it may be that we achieve yield increases by something other than input responsiveness. But when a plant responds to inputs like nitrogen or water, it means that they're inherently limited for nitrogen or for water to begin with. And plants, so if you made a legume that was nitrogen responsive, likely it wouldn't be a very good nitrogen fixer, so it needed the nitrogen that you would give it. Or you made a plant that was water responsive, likely it had lower innate drought tolerance and so on. So I don't think that the simple analogy with grasses that legumes should be more input responsive is really a good idea. I kind of think be careful what you ask for. You might make systems that are less resilient and less sustainable, which, if that was the case, would both be poor outcomes. What we really need to focus on is yield and resiliency. I'll mention a genetic resource that I think can be used to tackle these sorts of problems. And of course, Professor Sadiq talked about this exactly in the case of drought tolerance. But the kind of traits we might want would be things like increased efficiency of nitrogen fixation rather than more dependent on inputs of nitrogen. Better water use efficiency rather than more dependency and more responsiveness to input water. More disease resistance rather than having to add fungicides and so on. I guess I think you get the point. It was the point, another recommendation, and this has been made by a previous speaker. So we need increased investment in pulses. For me, one of the large reasons why pulses lag behind is because we simply have not invested in them properly. And how in the world could we expect to keep up with the yield in the grasses, given the massive investment there, if there's essentially no investment in pulses? It just doesn't make sense. I think it's also important to keep in mind what led to yield changes in cereals. And at a general level, at the risk of being overly simplistic, less than half of the increases in yield in the grasses is due to genetic gains. Most of it's due to agronomic practices. I would also point out that the modern traits that have been most successful are not traits that increased yield. They increased profitability and resiliency. And I'll just point to herbicide tolerance and pest resistance. So there are different ways to sort of skin the cat, as it were. And I think that input responsiveness might not be the best way to go. So the program that I'm going to tell you about is a partnership. It involved a number of different funding agencies. It involved researchers in different parts of the world, including in Pakistan. And in my program at UC Davis, largely, but not exclusively, under the umbrella of the USAID program that brought together research in Pakistan and researchers at UC Davis. I've had the pleasure of training 9 different students. And I'll mention, and visiting scientists, faculty in Pakistan. I'll mention the work of 7 of these individuals who have worked on pulses, which means I specifically won't talk about the work of Cerise Sajaz, but I want to recognize the work that she did in the laboratory on viruses. And I won't mention the work of Rizwan Tufail, but I do want to acknowledge the really excellent work that he did on bacterial blight in cotton. And I won't talk about their work further because it's not pulses. In terms of chickpea, in my laboratory, a large part of the work over the last few years is focused on trying to harness the diversity and potential of wild systems, particularly the wild crop progenitors, Cicer reticulatum and Cicer canispermum, to meet agronomic challenges, and working with a large team of international scientists, including a significant group from Australia. We surveyed and collected material from southeastern Turkey in the northern Mesopotamia region. And we collected seed from wild species, and we collected the microbes from those organisms, often on roots. The reason for going back to those wild systems was the simple observation, which we were able to document in greater detail, that genetic diversity is limited in the domesticated species. It turns out that there are shifts in diversity not only in the crop, but also in the microbes, by the way. And those wild systems have diversity that's unique relative to the crop. Not just do they have more diversity, but they have traits that are absent from the crop. And so a simple question would be, are there traits in those wild systems that could help with agriculture? The kind of traits we're interested in are tolerance to climatic extremes, drought, heat, among those, nitrogen fixation, disease, and pest resistance. Microbial associates, the microbiome in the wild species, could that help with plant health, soil type adaptation, seed nutrient density? These are the primary areas that we focused on. Now, once we collected those wild material, one of the things that we did early on, there were a number of activities that happened in parallel, but one of them, you know what I'm thinking. Can folks hear me okay? I know I'm stopping here for a second, but I'm a bit worried that I may be talking into my screen.
Your slides
You
are
can hear
good.
me?
Yes, we can hear you.
Okay, and you can see the slides. I think I probably just put them up. I apologize for that. You've verbally heard what I said. One of the first things we did after we made collections was initiate a series of parallel activities. And amongst those parallel activities was the development of pre-breeding populations. It was taking a representative set of wild material. We had sequenced over 1,000 wild genomes and about 50 cultivated genomes. And so we had a sense of what diversity was like. We made a decided choice of wild material to make genetic crosses with. We took 20 diverse wild accessions and 5 cultivated accessions. We generated about 9,000 unique lineages, which are now at F5 and F6. And that's the point where phenotyping can begin. Now, I should say that there was a large team of individuals who helped build these populations. It was not only crossing, but maintaining and screening. And one of the scientists who was involved is Dr. Gulshah, who received his PhD in Pakistan, but based on work done in my laboratory, and then worked for a period of time as a postdoc. And this is Gul and I in the field a couple of years ago when the plants, I think, were probably at F3 stage. And they're really an amazing set of traits that come out of that material. Those populations that we built, these pre-breeding populations and eventually breeding material, were distributed around the world where they're being worked on by different breeding programs who have different traits of interest in mind. So they're present in Ethiopia, India, Russia, Australia, a number of different countries. I should say I don't think there's material presently in Pakistan, so maybe that's an issue to address. So what I've just told you about is we made collections in these wild systems. That's the map at the top. We made these crosses into cultivated lines to develop pre-breeding and breeding material that could begin to be screened for agronomic traits. And the kind of traits that we're interested in, where we found differences, were heat tolerance, resistance to insects, particularly pod borer, ascochyta blight, drought, and so on. Our goal is to find the genes that underlie the traits, or at least markers, so that we can do predictive breeding or genomic selection, however you would like to talk about it. But we're also interested in understanding mechanisms. So now I'm going to tell you a series of stories. One story is about pod borer, and a very important polyphagous insect on chickpea that I'm sure you're all aware of. We had screened initially with an Ethiopian student when he was at ICRSAT, funded by our program at UC Davis. We had screened wild material and found a whole series of wild genotypes on the right-hand side here that were much more tolerant, one might even say resistant to the pod borer insect than even the best of cultivated lines, which are shown up here between the blue and the gray area. So these are significantly more able to deal with this insect pest. And when Go was in the lab, one of the things that he did was to repeat the screening that had been done in India, was able to recapitulate those initial results at UC Davis, which gave us confidence that what we were looking at was likely useful. We started to explore with groups at UC Davis and at Assam in India, the metabolic profile of chickpea plants, and to test the possibility that unique metabolism might underlie pest resistance. But this is an ongoing project, but one that involved, in an important way, a Pakistani scholar. Another topic is drought tolerance. Professor Sadiq just gave a very nice talk on drought tolerance. We focused also at the physiological level, but where the goal was to understand the molecular processes that underlie drought tolerance. And with this approach, we looked at both physiology as well as transcriptional profiling. And this is a project in which we trained a number of PhD students. This is a photograph from an outdoor lysimetry at ICRSAT. One of the things that we identified, and if you look at the upper left-hand corner here, you'll see two cultivated lines, ICC 14778 and ICC 8085. One is tolerant to drought and one is resistant. And two wild species, two wild lines that came from relatively arid natural environments. And all this graph shows is that these wild lines have a significantly increased water use efficiency under increasing drought relative to even drought-tolerant cultivated. So there's a lot more to this story to explain it properly, but the point is that we see variation in drought tolerance in the wild material that exceeds that of the cultivated lines, and this suggests there's likely to be significant value in these pre-breeding wild by cultivated hybrids. We took this material, we did a transcriptional profiling on several hundred different treatments and accessions. And one of the things that we observed, which was quite interesting, and it's depicted in the lower left-hand corner here. I won't refer to the data though, but I'll just tell you the outcome. And there's a huge transcriptional differentiation, even in the absence of drought, between wild and cultivated species. Just like wild and cultivated are very different at the genetic and genomic level, so they are also substantially different in terms of their gene expression. Moreover, cultivated lines, you could choose different cultivated lines. They tend to have very similar transcriptional profiles, whereas wild material, different genotypes have very different transcriptional profile. In other words, the wild material is not only different from cultivated, it's also substantially different. The lines are substantially different from one another. There's huge diversity in transcriptional capacity in the wild material. And this is a very general statement. How that might relate to traits and so on is a much more complex problem that I can't tell you the answer to at this point. On the right-hand side is simply shown an experiment. We look at the number of up and down regulated genes and so on. Again, I won't go into this except that we have a lot of transcriptional profiling data. This was just published, this particular work was just published in Plant Journal. Now, the reason for telling you all of that is that part of the team was two Pakistani scholars, Dr. Atif Rana at UAF and his student, Mohammed Waqas. And Mohammed Waqas was particularly interested in a gene family known as aquaporin. These are intrinsic membrane proteins involved in the passive movement of water and uncharged solutes. They're very important in drought tolerance, but also other physiological processes. And when Waukes was in the laboratory, he dug through the genomes that we have and the transcriptional data that we have to characterize the 4 major families of aquaporins, this important family of water channels, in both chickpea as well as in wild relatives and in other plants. And to try to understand the evolution of these families and whether or not chickpea, where chickpea might have had expansions in certain family members. And this is a part of his PhD work that will be published in the not too distant future. And Waukes also took, after identifying the genes, went and looked at transcriptional differences, again, work in progress, but you get a sense of what he's doing, identifying genes, understanding their evolution, and looking at their regulation in response to drought. Another piece of work that we did, also led by Gul Shah and his major professor, Dr. Farooq Muniz, was to look in Pakistan at land races. Gul collected approximately 80 Pakistani land races. We sequenced their genomes. We looked at their genetic diversity. This just shows the origin of the different materials that Gul collected and the aridity associated with those areas. This was published in Plant Genome, I think the year before last. This is a phylogenetic tree of that material. It just tells you that the genotypes from different areas are often related to one another. The outcome of this work was to identify a small number of single nucleotide polymorphisms, about 200, a bit more than 200, whose presence and frequency assorts with the level of drought in the Pakistani environment. And these are candidate SNPs for drought tolerance in Pakistani germplasm. Again, that's a hypothesis that one would have to test. So quickly, I'm going to tell you a bit about work with symbionts, pests, and pathogens that also involve Pakistani scholars. Significant focus of my work for the last several decades is nitrogen fixation. I don't need to go into this. You all know nitrogen fixation is important. We published a paper in PNAS last year that basically described massive diversity of the microbial side of nitrogen fixation, a genus known as Mesorhizobium. At center of origin, we find 2 species of Mesorhizobium, but if you go globally into cultivated chickpea, every time you go to a new country, you find a set of new species of Mesorhizobium. That is, there's massive diversity of this important microbial symbiont that fixes nitrogen with chickpea globally. And there are a lot of interesting implications of this. But one of the things that we did, particularly working with Kashif Reyes at UAF and his students, was to make a small survey of Mesorhizobia from chickpea plants in desert regions of Pakistan and sequence those genomes. These are the sampling locations. And with a student at UC Davis, those genomes were sequenced and analyzed. The take-home message here, and this is a manuscript that's getting ready to go out for review, is that Pakistan also is characterized, its chickpea fields, by symbiosis with Mesorhizobia. But all of the species in Pakistan are novel relative to what's found elsewhere in the world. We identified 4 new species of Mesorhizobium that are predominant nitrogen fixers in chickpea fields. Whether those microbes have unique functionalities is an open question, but now something that someone can explore with a rational platform. Another piece of work that we did, also involving Pakistani scholars, in this case Farooq Muniz, when he was on sabbatical in my laboratory, I should say Professor Muniz, I had collected some Ascochyta infected leaves in Ethiopia. That's the picture on the left-hand side. I brought them back to the laboratory. I gave them to Professor Muniz, who cultured those organisms, purified them, ran virulence assays, determined that they would cause Ascochyta-like symptoms in the greenhouse. Professor Muniz sequenced their genome. A student, Kaylin Badger, came along, did the assemblies and the analysis, and determined that this organism from Ethiopia that can cause Ascochyta blight is in fact not Ascochyta. It's a Phoma species, related organism, but a distinct species from Ascochyta rabii. Its genome is different, only 85% similar at the nucleotide level, but has a very similar gene content out of about 7,800 genes in either genome Ascochyta or our new Phoma species. The vast majority of them are common to both. And there's a lot of interesting insight gained from looking at these genomes that I won't go into, but we're working on Ascochyta blight. Another project, which has been a major emphasis in the laboratory and started with 2 Ethiopian students shown here on the left, but has in particular really gained benefit from Dr. Amna Fayez, who had been in my laboratory as a student, by the way, but is now back as a postdoc working on Fusarium wilt. And this is Fusarium wilt in Ethiopia. It's a very important disease of chickpea. We had the 2 Ethiopian role, Dr. Fayez's role, was to take that genomic data, assemble the genomes, and begin analyzing it. And in a nutshell, she was able to confidently identify the majority of the strains as Fusarium oxysporum, understand the relationships of those strains to one another. Everything in orange is Fusarium oxysporum. A smaller number of the organisms are other Fusarium species. We've begun to test virulence of these organisms. We've begun to identify disease resistance genes against them. One of the things that Dr. Fayez has done is to start looking at the diversity of the pangenome of Fusarium oxysporum. Turns out the average out of 120 high quality genomes, they have an average but less than 20,000 genes. But the genes that are shared in common amongst that set is only about 75% of the total. Conversely, there are at least twice that many genes that are variable at relatively high frequencies amongst those strains, and then a much larger number, 160,000 genes in total, that are found at very low frequencies in individual or small numbers of genomes. So this represents the plastic part of the genome that might have important roles in virulence or other kinds of environmental adaptations. And this is where the project is headed, is to try to understand the relevance of that diversity. Finally, we had looked at the microbiomes of chickpea plants in the wild systems. This is a project led by Betsy Alford using 16S and 18S sequencing. One of the things that Betsy had also done, now working in collaboration with a visiting HEC scholar, Dr. Rabia Mufti, was 700 different genomes of these organisms. Now we can tell what species they are, how they're this important chickpea pathogen that I just told you. And amongst the organisms that she found were 3 strains that turned out to be Pseudomonas based on their genome sequencing that could inhibit Fusarium oxysporum. And surprisingly, when Betsy went and started looking at their genomes, they all carry a very well-conserved biosynthetic cluster for a polyketide known as diacetylfluoroglucanol. And it looks like I have diacetylfluoroglucanol, which is a well-known antibiotic involved in biocontrol. So there's a pretty good chance, I think, and these organisms are very abundant on the roots of chickpea plants. So I think we stumbled, without intending on it, into a situation of natural biocontrol that involves production of this important antibacterial metabolite in a bacterium or from a bacterium that's a very abundant member of the chickpea microbiome, and maybe it has practical applications in disease control. So this is what I had to tell you. It's a series of small vignettes, and they're quick stories, so I hope it was possible to follow them, telling you about the work of my laboratory, but in particular how that's involved Pakistani scholars. I'm not sure where I'm at with time, but I will stop there.
Thank you, Professor Cook. I think you have really made our day. We started from political economy of pulses and chickpeas. We talked about WTO rules which control import and exports and our policy deficit. And then Professor Sadiq presented a very elaborate drought relationship studies. We will have him finish his study because finish his talk because we were lost due to internet problem. So he's back, and before we open the session for some question answer, I will ask Professor Sadiq to finish his remaining talk.
Thank you, Professor Khan. My apologies, I don't have many more slides, but if you allow me and permit, I'll finish it off, and thank you again. Can you see the slide?
No, you have to share it.
Not yet.
I have been sharing, so I said I'm sharing.
Try again.
I'll close that, then go and share. Just give me 1 second, please. How about it now?
Yes, yes, it is
Okay,
there.
so this is where I left. We have developed a fantastic phenotyping platform on root studies, not only in chickpea, a number of other crops. Here we taken the 300 so-called the reference collection, which represents the world collection. We were able to accurately phenotype 35 root traits, and I'm here showing an example here, and I'll just show the this is the taproot length, where the Desi type showing significant variation, the Kabuli type showing variation, and these are all available for our future work. I think I have summarized this. Is this correct? I've already covered this. Yes. Okay. Can you hear me?
I think we lost you at this slide.
Okay, so this is where the summary of the drought work. So we get reduced yield, the drought, and I showed that pollen sterility, pollen viability, possible fertilization failure, flower abortion, pod abortion, cessation of the seeds. So there's a lot of work to be done there, and reduced seed yield, but also the role of ABA, the carbohydrates we have been sorted out. And of course, the root system is the one which is pumping water. We need to work on that. We heard from our third speaker that the genomic assisted selection breeding needed. But if you focus on very simply the genetic resources, Doug Cook has very elegantly made some case for that. But we need improved germplasm for the farmers. That is what our ultimate aim. We don't get carried away with the technology. The technology is just a tool, but we must use that, whether it is genetic mapping, EST sequencing, genome sequencing, or QTL mapping, or now using some of the technologies like Doug mentioned, transcriptomics, proteomics, metabolomics, and so on. So finally, the phenotyping, the trait QTL evaluation, genes, genotypes, these are all important. We have been able to sequence the 429, which is the reference collection plus that information is available and being utilized. And in fact, a couple of new varieties just released in India and Ethiopia based on that program. We are also worked on the population structure within Australian genotype. What we're finding is that Australian breeding lines have got narrow genetic base. So we started introgressing with the ICRISAT-derived lines, and we have been able to make a significant shift in that bottleneck, or change in that bottleneck approach. We have also worked on Jivas. Can you hear me? Can you all hear me?
Yes, yes.
Yeah, good. So the Jivas result, don't get too much, I don't want to talk too much about it. We looked at the grain yield, seed number, the empty pod ratio, early vigor, and a number of other traits. We are working on the roots as well. The main point is that the regions containing the SNPs significantly associated with different traits are highlighted with red rectangles. So it's not like we are also moving towards that. Yes, there has been advances in wheat and maize and rice. And I think the concentrated effort from groups such as Doug's group, my group here, the ICRISAT group, and ICADA group is making significant progress towards achieving applying GWAS and genomic approach in breeding programs. Most of these things are published, so I'll just flash that through. You can contact me if you want, or you can go directly to the web and find out whether it is the root system, the pattern of water use I mentioned, the GWAS work, and more recently, we put a review paper in order to bring the genomics work with the phenotyping system, more importantly, agronomy and seed production. So my final slide, Professor Khan, we must strengthen the breeding process. So what are the strategies? So if you look at this pillar, maximizing genetic diversity, that's what Doug was talking about, sequencing and genotyping of germplasm collection or rhizobial collection, phenotyping of high input, high throughput platforms. That's what I've been talking. Simulation and crop growth models, I haven't touched that. That's an important area. Development of diagnostic markers, sequencing-based trait mapping, and gene discovery. That's not enough. We need to really translate that into the improved genetic enhancement or breeding program. Large number of crosses still need. You heard from Doug, he has been making crosses of the wild crosses. Large segregating breeding population. If you don't have that, there's not much to select. Early generation screening, we are scared of that. Generally, the breeders wait till F4, F5, it's already lost, becomes homozygous. Genome-wide prediction is needed. We need a predictive approach rather than the black box approach. Mass and molecular backcrossing, rapid generation cycling. Our group in Western Australia, UWA, can generate chickpeas 4 to 5 generations within 1 year, up to 6 generations, using different light regimes, different tissue culture method, and so on. Then, of course, genome editing. We heard the Nobel Prize for the CRISPR technology. So genome editing will have a role to play, but that's not enough. Improved operational efficiency, appropriate experimental design. We need the biometricians. Field book is replaced by big database recording, analytical and decision support tools. Liz mentioned about that. Use of breeding databases and sharing that database, integration of digital tools, technology across the breeding process, and screening. And we heard from the first 2-3 speakers, it's not enough. Efficient seed system is one of the major limitations. For example, a chickpea crop in Pakistan, the farmer has to put anything between 80 to 100 kilograms per hectare. And that's a lot of seed. How can you multiply that seed enough to cover your country? So strengthening the formal and informal seed system is an absolute must. I think Liz mentioned in her talk, faster varietal replacement rate. If you go and look at Pakistan, many of the varieties have been there for 10, 15 years. We cannot continue like that. And the varietal release committee makes a decision up to 7 to 10 years to release a variety, even after the variety is developed. Timely availability of affordable, high quality seeds, particularly small farmers. Better soil health and optimized agronomic practices. We need to re-look at the agronomic practices in Pakistan in pulses. Are they up to date? Are we still continuing the old practice? Access of farmers to markets through digital and agricultural tools. You heard from Liz and Ajinder that market is a limitation. So, input from stakeholders needed. So this is why we need an integrated approach, higher genetic gains. Without that, the farmers won't adopt that variety. Increased productivity and production, integration with the value chain, and increased farmers' income. I think this will lead to a significant expansion of pulses in Pakistan, and an integrated approach is required. And I'm happy to work with the academy and the universities with my group from Australia. Thank you very much, and my apologies for the problem with the internet. Thank you.
Professor Sadiq, you have concluded it very nicely. Your last slide says everything. Okay, so folks, we have overshot our time limitation, but it's been such a wonderful arrangement that we have heard from political economy to CRISPR-Cas and the Nobel Prize winning. This week, there are two Nobel Prizes which are relevant here in today's session. The one on the World Food Program and the other on CRISPR-Cas. Okay, two discussants. I'm told that Zulfikar is part of ACIR new Pulses program, so I thought that let's hear from our Pakistani counterpart how they are trying to interact with the ACIR program, and then at the end we will hear from the ACIR boss in Pakistan, Dr. Munawar Kazmi. So Zulfikar, first your initiative, and then Dr. Kazmi will let us know the final word. Munawar, Zulfikar.
Thank you very much, sir. Thank you. Are you hearing me, sir?
Yes, you're fine.
Yeah, thank you. The speakers of this webinar, they well presented the situation and the production profitability of the pulses in Pakistan. And what we were dealing is the four interventions we were doing with the help of ACIR. And as the speakers, they have mentioned the problems of Pakistan pulses production. The number one is the seed. So in the seed sector, we were intervening through the farmers, farm families. And there were 90 farm families in this project throughout Pakistan at 6 sites. And we were helping them to produce the quality seeds and then getting it certified from the federal seed certification. And then that will be provided to the other farmers. So last year, we have 54 tons of certified seed, which is going from the 90 families to the surrounding. And the other, we also involve the NGOs and the private sector as well. And they were also part of this seed production system. So with the interventions of the quality seed, there was a significant increase in the yield. On an average, if I see the 90 farm families, they were sowing 1 acre of the chickpea, and they have 1.5 ton per hectare of their yield. So if we say the yield, national yield of the chickpea is this year it was 0.55 ton per hectare, but the farmers, they are 1.5 ton. So another interventions were about the weeds, removing the weeds, then giving a demonstration trial for the weed removal and then its effect on the yield. And there was inoculation with the different bacteria, and we got from the Australia, and we also have from NARC, and that also impacted the yield. Another thing which I think is necessary to be addressed in the pulses is the machinery. Harvesting is manually being done, and there is a problem of with the farmers, and due to that the crop is over mature, and the shattering and the harvesting losses are there. So as in the project that started in 2015, and if I say from the interventions of this ACIR throughout Pakistan, there was the presence of the scientists from different institutes with the farmers, and with this sport, the yield increase. And if I say from the economic survey in 2017, we were producing 0.35 million tons out of 0.97 million hectare. But this year we have 0.55 million ton out of 0.94 million hectare. So it added the presence of the researchers with the farmers added 200,000 ton in the pulses basket. So another intervention which we like is as you know, the pulses, we say it is very important for the humans, but I think it is very important for the cropping system as well. If as Liz Peterson indicated that we and she recommended to remove the ban on the exports. But I would say if the marketing or the prices of the chickpea, they are brought to the international level, there is a difference of around 0.8 cent per kilo. So this difference is impacting a lot. And if it is increased, the pulses will go into the irrigated areas as well. And once these are going to irrigated areas, they ultimately they will be fitting in the cropping system, and they will also help for the other crops production as well. So in my opinion, this increase in price will certainly improve the agriculture sector in Pakistan. So with the help, I would say with the help of this ACIR project, in my view, this 200,000 ton come to the pulses basket. The credit is going to ACIR, and now the Pakistan government also involved. PSDP program is there with the NARC and PRC and other organizations. They are involved, and once the researchers, they are in the field, basically they are helping the farmers, and ultimately their productivity and profitability is increasing. So this project has impacted. It will further strengthen this availability of seed in the project. We also engage the entrepreneurs, and we are trying with the help of NGO to develop the seed system, informal seed system like these seed banks in the villages, and the sharing of this. So if the quality of the seed is improved, and although there is among the farmers informally, that should be certified like we are doing in the project, that the farmers, they are growing their crops for the seed, and we are helping them to get it certified from the federal seed certification, meeting the standards of the certified seed. So I think this is impacting. So it's all from my side.
Thank you, Zulfikar. Okay, folks, we move on to the concluding remarks before we take any questions. Are there any questions before I ask Dr. Kazmi to conclude it? Any questions, comments from the audience? 2 hours, I think people are already tired and, intending to leave. All right, Kazmi Saab, over to you to give us a final word on ACIR engagement in pulses and chickpeas. You are going to run it for next several years. So what is the outlook, and what do you intend to achieve end of the day?
Thank you. Thank you very much, Dr. Saab. बहुत बहुत शुक्रिया. It's an honor, and we are very happy that ACIR is being acknowledged and Australian government is being acknowledged. Let me thank all the participants, especially our speakers. I am really impressed the way Dr. Kadambot Siddique has shared his work, excellent work. Douglas from California, I think it was wonderful. It's really impressive work. And just to add what Dr. Mubarak has started saying in the start, he said that policy makers can make difference, but the scientist has to work. I would like to add into that Dr. Douglas' work and Dr. Siddiq work shows that the support from the policymakers can make scientists to deliver. So I think this is a very important step from the Pakistan Academy of Sciences for this sort of arrangement. Dr. Sab, in Pakistan, ACR has at the moment 3 projects on the pulses. One is the production, on the production side, which Dr. Zulfikar has mentioned in detail. The other one is the pulses value chain project, which is just started before the COVID-19. We signed the project and we were about to start, and field teams have already activated on ground in Pakistan. And the third project is AVRDC implementing a project on Mung bean. It's a regional project. Pakistan, Myanmar, and Bangladesh are part of that. And these are the current projects, and all these 3 projects are based on a short research activity which was led by Dr. Liz Patterson from University of Western Australia, in which we analyzed the policies and the situation of pulses in Pakistan. And I think that short research activity of 1.5 years helped ACIR and Government of Pakistan to work on these 3 projects. The 4th project, which is we have started negotiation, and that will really help our national scientists, is on establishing a speed breeding facility at NARC Islamabad, where we are trying to bring University of Western Australia to work with the NARC scientists, and we are helping, going to help NARC to establish the speed breeding facility, which we believe that it will help the to add into the value of the seed, which is the most important thing. I think as Liz has said, that the aim of ACIR work in Pakistan has been to promote the local science, local scientists, and bring in the Australian expertise and the Australian knowledge to help Pakistan for this industry. I think there has been a lot of debate on the policy side, so I will not touch that. The export ban and the wheat, we all in Pakistan, we all know how these decisions are important and how the governments have to make the decision. But I would like to really appreciate one of the comment made by Dr. Mubarak, that our government and the policy makers has to decide between the rice export and pulses import. And he has presented an excellent comparison that how much we earn by export and how much we spend by importing. So I think we need to work on this, and I look forward to have the support from Pakistan Academy of Sciences and Dr. Iqrar Saab especially to help in lobbying in the government that whatever the scientists are doing, it needs to be supported by the policymakers. As an international agency, we can only suggest and present an options to the government of Pakistan, to the policymakers for their consideration. We cannot force them to make changes in the policies. Definitely they have their own criterias, but we would like to have an open dialogue at any forum with our policymakers, with the researchers, and I look forward for ACR's support, and we look forward for the support from the Pakistan Institute, especially the University of Agriculture Faisalabad has been a great support to our projects, and now the Multan University, MNS University Multan is coming up, and then Arid University. So academia is all there with us, and we look forward to engage the important part which was missing is the private sector. And in our value chain project, we look forward engaging private sector, so that whatever we do, we ultimately share it with the private sector. So with these words, sir, I am grateful for your for this opportunity, and I'm always here from the ACR side to extend any support and any help needed for the pulses sector or for the other cropping sectors or agriculture sector in Pakistan. Thank you very much, sir.
Thank you, Dr. Kazmi. We are grateful to you for your cooperation, and we look forward to our continued collaborative arrangements. Before we close, I would like to mention that next week we will have two major events. First, on the 16th of October, World Food Day, and we will celebrate a talk by this year's World Food Prize recipient, Dr. Ratan Lal. Ratan Lal is the current year's World Food Prize recipient. And then on the 17th, our regular weekly webinar would be on citrus genetics and breeding. We will have two speakers from University of California, Riverside, and one from Wuhan Agriculture University. I look forward to your continued support, and I say goodbye for now, and thank you very much for your concentration and participation, particularly two speakers from California and Western Australia, our lead speakers, and then two of our policy speakers from ACIR sponsored project, and Dr. Mubarak also was very helpful in organizing this event. Thank you very much.
Thank you.
Thank you.
Good night, everyone.
Good night.